Okay, so let's work this problem of the ice block being pushed across a frozen lake. And we're told that this guy is pushing at an angle of 25 degrees below the horizontal. So at a glance, this seems like kind of an easy problem, but it turns out this is a kind of a tricky problem. So let's identify the forces here. We've already identified one of the forces here in the diagram, but we always have weight pulling down, and that's mg. And the normal force pushes back up. Now, pushing to the left is the force of static friction. And in this particular problem, we're asked, how hard does the guy have to push to make it finally move? So when the block finally moves, the static friction force is at its maximum. So this is actually the maximum force of static friction. Okay? So let's go ahead and draw our free body diagram here. Okay? So standard X and Y axes. And let's put our forces in here in red. We have mg downward, normal force pointing upward, our maximum force of static friction to the left, and then this force F, which pushes down this way at a 25-degree angle. Okay? Now, what else do we know about this situation here? Well, we basically know what the acceleration is right at the very point when this is about to move. So, right before this thing's about to move, the static friction force has reached its maximum. Okay? But it hasn't started moving yet, so our acceleration is still 0. Finally, we exceed that force, and it starts to move. So right when we're at the very point when this block is about to move, static friction is at its maximum, acceleration is still 0. Okay? So acceleration is still 0. I mean, it's just about to not be 0 anymore, but right at this point where we have the maximum force of static friction, our acceleration is still equal to 0. Okay? So if that's the case, Newton's second law, mass times acceleration, okay, acceleration is 0. So we have, again, an equilibrium situation, basically, where the forces have to add up to 0. Okay? So if the forces have to add up to 0, that will allow us to solve this problem. So let's go ahead and do that. And remember, this is a two-dimensional situation, so we have to do it for both the x and the y component. So the x component, the x forces, since the forces add up to 0, the x forces have to add up to 0. And the y forces have to add up to 0 as well.